Now just imagine one day when you come to school, you realize you haven't brought your tiffin. So you are hungry, what will you do? Probably you will ask your best friend. Now the best friend is in a dilemma. If he gives you the tiffin, then he goes hungry. If he doesn't, then the friendship is broken, or he will be labeled as selfish. So what do? You share your tiffin. That is exactly what carbon does. Carbon shares electrons. The 4 electrons deficiency is fulfilled by sharing. This kind of bond is called covalent bond. It is not just the carbon which shows covalent bonding. There are many other elements which also show this kind of bonding. Let us take the case of hydrogen. The atomic number of hydrogen is 1. So in the K shell there is only 1 electron. Now it wants to be like helium, because helium is the noble gas, nearest noble gas, and that has only 2 electrons. So which means it has to gain 1. But who will give that? So what happens is that there is another hydrogen atom and both share their electrons. So what becomes of it is a hydrogen molecule. So for the formation of hydrogen molecule, there is a covalent bond between hydrogen atoms. Let us take another case, oxygen. Atomic number is 8. So first shell will have 2, second will have 6. Now this also requires 2 more electrons. Once again sharing with second atom. That means now the sharing is between 2 electrons. So whenever there is sharing of 1 electron, it is called single bond, and the compound is called, or the molecule is called saturated, that means fully satisfied. And when there is double bond, or there are 2 electrons shared, then it is called double bond, and this is called a unsaturated molecule. Now not only hydrogen and oxygen, there are others also, like nitrogen. The atomic number of nitrogen is 7. So the first one will have 2 and then 5. Now it needs 3 electrons. So another nitrogen atom, so 2 are free but 3 are being shared. So when 3 electrons are shared, it is called triple bond. This is also unsaturated, and the resultant is nitrogen molecule. The properties of a compound depends upon what kind of bonding it makes. For example, in the case of ionic compounds, we saw that the bond was electrovalent because there was either loss or gain of electrons. Now in ionic compounds, the electrostatic force of attraction is very high, and what is the result? The result is that ionic compounds have high melting point and boiling point. On the other hand, the compounds showing covalent bond, they have weak electrostatic force of attraction. So their boiling points and melting points are low. For example, many of the carbon compounds like carbon dioxide, methane, ethane, they are all gases. So, we can say the first point is weak electrostatic force of attraction. And what is the result of this? Low melting point and boiling point. Secondly, because there is sharing of electrons, there is no loss or gain of electrons, there is not formation of charged particles. There are no anions or cations. So, what is the result? It is a bad conductor of electricity. In the case of ionic compounds, in their molten state or solution form, they are good conductors of electricity. In the case of carbon, there is one more advantage, and that advantage is that the bond is short. Why it is short? Because the distance between the nucleus and the outermost shell is less. So, the electrons are always attracted towards the nucleus. Why is it less? Because there are only 6 electrons which get distributed in 2 shells, K and L, 2 in K and 4 in L. So, the bond is short. Now, imagine if an element has high atomic number, the number of shells will be more. So, the effect of nucleus will be less. Now, let us take the case of water. In case of water, there is oxygen having 6 electrons, and then 1 electron is shared with 1 hydrogen and second one is shared with second hydrogen. Now, this time instead of dot I have used, instead of cross I have used dot. Why? Because hydrogen is another element. So, what we get is H2O. So, everybody is satisfied? That means there is a single bond. Similarly, in the case of ammonia, there is nitrogen and there is a need of 3 electrons. So, 1 hydrogen, second hydrogen, third hydrogen. So, 1, 2, 3, 4, 5, 6, 7 and 8. So, it is like this. NH3. The carbons also attach with hydrogen, and the simplest form of hydrocarbon is called methane. Its formula is CH4. That means one carbon atom will be attached with 4 hydrogen atoms. This is carbon, this is 1 hydrogen atom, this is second hydrogen atom, third and the fourth one. So, basically what we get is CH4, 4 electrons of carbon and 1 each of the 4 hydrogen, total is 8, and each hydrogen is also getting 2. So, here also there is a single bond and a saturated compound. So, all these compounds are showing covalent bond. Another interesting thing about these molecules is within the molecule the bond is very strong, lot of force of attraction, but intramolecular the force of attraction between different molecules is weak, and that is why most of these are in the form of gases. They are found in the gaseous state.